Hello, I am Tanjim Taharat Orpa, the presenter of this paper. The title of my paper is Discovering and Tracking Query-Oriented Topical Clusters in Online Social Networks. My co-authors are Fatima Khan and Dr. Muhammad Mushfiq Anwar. With due respect to everyone, I am starting my presentation. This is the outline of my presentation. Come to the introduction. Online social network is a very common platform where individual users can represent them virtually and communicate with each other. During COVID-19 outbreak, we can see that online social networks are become very popular. Some users who were inactive before this outbreak become active during this outbreak. And maybe after the outbreak, they will become inactive again. So we can say that people's interest or activeness is changing over time. So we can clusterize these people over their interest and the topic they're sharing. What is a cluster? A cluster is a group of users who are nearly associated and interact with each other and have the interest on similar topics. So here we discuss the state of the art. Some approaches has been introduced based on topics of interest. Topic profile was developed in 2010. Topic profile was developed for individual users, and it was checked by the categories appeared frequently. In this approach, they focused on discovering the topic of interest for individual Twitter users. Some approaches has introduced based on textual similarity. In 2016, they are introduced an approach based on textual similarity. In this approach, they compared k-means and the simple k-means and the spectral k-means algorithm for find out the textual similarity. All this method ignores topic-wise user activeness. Also, they are unable to trace active clusters. In this paper, we proposed an approach to identify and track users' topical degree of interest over time and identify clusters based on that. We showed how user activeness is changing with respect to time. We accomplished comprehensive experiments using real data sets to show that how much efficient our approach is. To understand the problem definition, at first we need some preliminary knowledge on the basic terminology. So first comes attributed social graph. An attributed social graph mainly represents the social network. It is denoted by G and consists of three attributes U, E, and A. U represents the set of social users or nodes. E indicates the connection between them or the edges, and the last attribute A represents a set of topics discussed by the social users in G. Topic. A topic contains most representative words for certain concept. Activity. An activity refers to an action that a user performs at a time point. This activity is recorded as an activity tuple for user U and V. Phi UV indicates the topics discussed between them. Query. For our work, an input query is Q, which consists of a set of topics. Sliding time window. A time window of a predefined length is moved over the activity stream S and specifies the intervals to analyze. Topical interest score. For each activist user, UI belongs to U. we compute the topical interest score denoted by sigma to measure the involvement of each user, involvement of each UI belongs to U towards the given query attributes TQ of Q, where phi UI belongs to Q. Now we can discuss the problem definition. Given an attributed graph G consists of attributes U, E, and A, and an input query Q consists of topic T1, our purpose is to determine topical interest score sigma for each UI belongs to U. Detect topical clusters CH, CM, CL represents respectively high, medium, and low clusters, and cluster each UI belongs to U based on sigma. Let's have a look on the proposed framework. The proposed framework is divided into 3 stages. At stage 1, we cleaned the social stream, removed noise from them, and pre-processed that for our work. After getting the cleaned social stream, we applied Twitter LDA and infer the topic of each tweet posted by a user. And after learning about the topics of each tweet, we applied our topical clusters detection algorithm on that and determine users' interest, topical interest score, and clusterize them to high, medium, and low clusters. So we have used Snap dataset, which consists of 40 millions of node, 535 millions of ages, and 58 millions of activities. So let's have a look on our result. At first, we determine the cluster sizes for a fixed time window, 11 June to 17 June. Then we shift the time window from 11 June to 13 June. And we can clearly see that the cluster sizes has been changed. In first time window, where high cluster were 9, in second time window, it became 12. One user dropped from this cluster and 4 users added to this cluster. In the same way, the medium cluster and low cluster has been changed. So we can clearly see that by the change of time, the cluster sizes are changing. That means people's interest on this topic, Iran election, has been changing. We have represent a graph with the average interest score at different time interval at each topical cluster for topic Iran election. Here is the graph. To find out something more about user interest, then we try a different result, try to find out a different result. And in this case, we are able to detect bursty topic. So let's have a look how we can detect bursty topic by this cluster size. Bursty topic. Bursty topic is a behavior associated to a topic within a time interval in which it has extensively treated, but rarely before after. So to detect bursty topic, we have considered 2 values of our query input Q. One is Iran election and second is entertainment. And after choosing these 2 topics, we have shifted the time window again and again. For Iran election, we can see that at first and second time window, the cluster sizes increase highly, and the last time window it start to vanish. So we can see that at some point it has drawn to burst, and a other and after that time window it start to vanish. So its behavior is similar to bursty topics behavior. As Iran election was held 12th June, people posted on this topic a lot on 11th June to 18th June. But after that, people started to lose interest on this topic and stop posted on it. So Iran, we can say that Iran election is a bursty topic. On the other hand, the cluster sizes for topic entertainment always remains same. So it does not behave like Iran election or a bursty topic. So we can say that entertainment is a normal topic. Our observation will be more clear if we see this graph. The red curve is represents Iran election. So we can see that and 14 to 18 June, it is on the high peak, but after that its size start to decrease, and at last time window 26 to 30 June, it almost start to vanish. On the other hand, the topic entertainment represented by the blue curve is always remains same. So we have seen that how successfully our approach is able to detect bursty topic. I want to conclude my presentation by saying that detecting topical interest is core, and topical cluster and tracking their changes is the main concept of our work. We have successfully able to detect users topical interest, clusterize users depend on that, and then bring out some more characteristics about users interest. Thank you. If you have any query, you can contact with me and my co-authors. Here I have mentioned our emails.